This morning we're going to look at Section 3.3 Local Linearity, Example 2, Estimating the Square Roots of Integers Near 100. We're going to use a linear approximation of f, and the basic formula for a linear approximation is you evaluate f at a point and then evaluate the derivative at that point and use that as the slope of the line. So we're going to approximate with the tangent line. For doing square roots, 100 will be a nice number to evaluate both the number and the square root, and we'll use this to approximate square roots of integers near 100. We'd like to see how close our answers are to the correct answer. Our basic setup is set so the function f is the square root of x, our x0 is 100, f prime we're going to compute, we're computing it numerically. Recall that the linear derivative is f of x plus 001 minus f of x minus 0.001 divided by 0.002. So we need to set it up so that given our x0, we have x0 plus 0.001 and x0 minus 0.001. We're going to evaluate our function f of x at x0 plus 0.001 minus x0 minus 0.001. Take the difference of those two and divide by 0.002. That'll give us the numeric derivative, which we're going to carry over and say the numeric derivative. If I want to evaluate f of x, that's just the square root of our number, but my linear approximation, following what I had done before, the linear approximation is f at that point plus the derivative at that point times how far we're from that point. So I'm going to have b4, which was the square root of x0, b3, which is the derivative at x0, times x minus x0. My error is going to be the difference of these two numbers, and the percentage error is the error divided by the actual answer and then times 100 to make it percent. Once we have this set up, we can do quick fill, and with quick fill, we'll get the value at all of the points close by. So I now go back to formulas and turn my formulas off, and I see that 100 plus 0.01 is 100. 0.001 minus 0.001 is 99.999. I've evaluated the square roots. I've taken the difference of these two and divided by 0.002, and I get 0.05. So that's my derivative in my function. At x0, the two are the same, so there is no error, but it lets me compute at places close to this. In practical terms, I can compute the square root. I'm going to be able to compute the value of the function and the derivative at a nice point. They came out to nice even numbers. And then I can use that to approximate, and I see my percentage error for within 5 is less than 0.03%. So this lets me approximate square roots using the tangent line. Thank you.